Okay, for this problem, we're trying to find the angle theta here. So the sides that are given are the adjacent side and the hypotenuse. So we would write cosine of theta would be equal to the adjacent 10 over the hypotenuse 16. That's going to reduce to 5/8. And then since we're looking for the angle that has this cosine, we're going to use the cos inverse button. So the cos inverse of 5/8, and you pop that into the calculator. And we would get the angle 51.3 degrees for theta. For this second problem, again, we're trying to find this. And for this one, we're again given the adjacent side and the hypotenuse. So this would also be cosine of theta would be equal to the adjacent 8 over 9. Again, we're trying to find the angle given by this. So we'd go the inverse cosine, or second function cosine of 8 divided by 9 equals 27.3 degrees. Is the secant? For problem 3, we're looking for theta there. Okay, relative to that angle, the sides given are the opposite and the adjacent, so we would use the tangent of theta, the angle we're looking for, is equal to 7 divided by 16. We want to get the angle that has tangent of 7/16, so we're going to use the inverse tangent, or second function tangent of 7 divided by 16 equals 23.6 degrees. Similar problem here. There's our angle. Okay, the sides given relative to the angle are opposite and adjacent, so we would use tangent again. Tangent theta would be equal to the opposite 9 over the adjacent 13, and we want the angle that has this tangent, which would be the inverse tangent. Plug that in the calculator, and we're going to get 34.7 degrees. Okay, through this problem, we're finding all 6 trig functions. I know what the directions say, but that's what we're doing, is finding all 6 trig functions. So in order to do that, we first need to find the hypotenuse. We're going to use Pythagorean theorem. So 8 squared plus 15 squared is equal to the hypotenuse squared. 64 plus 225 is 289 equals h squared. So h equals 17. The sine of theta, here's theta, is equal to the opposite 8 over the hypotenuse. Cosine theta is equal to the adjacent 15 over the hypotenuse 17, and the tangent theta is equal to the opposite 8 over 15. Reciprocal of sine is a cosecant, so that's going to flip this, 17/8. Reciprocal of cosine is the secant, so that's going to be the reciprocal of that, which is 17/15. Reciprocal of tangent is a cotangent, which will give us 15/8. Same type problem here, only this one you're given the hypotenuse, you're not given this side, which we'll call b just for the base. So in this case, it would be 15 squared minus 12 squared is equal to b squared. So 225 minus 144 is 81 is b squared. So b equals 9. We have those guys. Start popping in these trig functions. Sine is equal, here's our sine, to the opposite 12 over 15, and we're going to have to reduce that fraction, but we'll do all these together. Cosine is equal to the adjacent 9 over 15, and again, we'll reduce that in a second. And tangent theta is equal to the opposite 12 over the adjacent 9. Okay, these both have a common factor of 3, so 3 times 4 is 12, and 3 times 5 is 15. Here, this is going to reduce to 3/5, and this is going to reduce to 4/3. The reciprocal of the sine is a cosecant. Reciprocal of 4/5 is 5/4. Reciprocal of the cosine is the secant. Reciprocal of 3/5 is 5/3. Reciprocal of tangent is the cotangent. Reciprocal of 4/3 is 3/4. Okay, another right triangle. We have to find the hypotenuse. So we use Pythagorean theorem. 9 squared plus 12 squared is equal to hypotenuse squared. So 81 plus 144 is 225 equals h squared. So h equals 15. Getting our trig functions, sine theta is equal to, here's theta, so it'd be the opposite, 12 over 15. That will reduce. Cosine theta is equal to the adjacent 9 over the hypotenuse. That also reduces. And the tangent theta is equal to the opposite, 12 over 9. And that reduces. So reducing these fractions, again, common factors are 3. We're going to get 4/5, 3/5, and 4/3. Reciprocal of the sine is a cosecant, so that will be 5/4. Reciprocal of the cosine is the secant, and that will be 5/3. Reciprocal of the tangent is a cotangent, so that will be 3/4. Same idea here, only this time we're looking for this side b, which is not the hypotenuse. So we're going to go 5 squared minus 4 squared is equal to b squared. 25 minus 16 is 9. So b equals 3. Okay, so sine theta, angle here, opposite 3/5. Cosine theta is equal to the adjacent over the hypotenuse, so 4/5, and tangent theta is equal to opposite over adjacent, so 3/4. Reciprocal, cosecant, flip the sign, we get 5/3. Reciprocal of the cosine, secant, flip that, get 5/4. Reciprocal of tangent, cotangent, flip that, we get 4/3. Okay, so drawing an angle in standard position with the measure of 660, and then giving the angle, or the reference angle form of the terminal side. So initial side starts out on the positive x-axis. Now we're going 660 degrees, which is almost 2 full revolutions. It's actually 60 less than 2 full revolutions. So a little hint on this: 60 less than 2 revolutions, right? So we're going to go here, 1 full revolution, and then 60 less than 1 more full revolution. The nearest x-axis from this guy would be 720, because that would be 2 full revolutions. So 720 minus 660, our reference angle would be 60 degrees. This guy would be 660 degrees. Okay, remember the reference angle is the angle formed from the terminal side to the closest x-axis. So there is our reference angle. On this guy, it's 350, again, positive. So our initial side, because it's standard position, will always be the positive x-axis. Since it's positive, it's rotating counterclockwise. 350 is 10 degrees less than 1 full revolution. So we would go here, counterclockwise, 10 degrees less. And again, 1 full revolution is 360. So the reference angle formed here would be 10 degrees. And this would be our angle in standard position of 350 degrees. So for these two problems, we're actually just seeing how you can measure angles in radians, just kind of some practice here to recognize things. Okay, so what we're trying to find is this angle right here. What we're given is this angle, 13 pi over 18, which is basically being measured from pi radians to this terminal side that way. Okay, so 1/2 revolution, right, going from here to here is pi. But since the denominator on the angle given is 18, we're going to write that as 18 pi over 18 minus this angle that was shown in green, the 13 pi over 18. 13 pi over 18 is going to give us 5 pi over 18 as the angle that is here. 5 pi over 18. 5 pi over 18 plus 13 pi over 18 is 18 pi over 18, which is pi 1/2 revolution. This problem, a little bit more drama to it because we're going for 1 full revolution and a 1/2 revolution and a little bit more. So we need to figure this out in terms of pi. And again, the angle that we're given here, which is coming off this vertical axis, is 7 pi over 18. So we're going to want to put everything that we're doing in terms of denominators of 18. 1 full revolution, our first full revolution here, this guy, is 2 pi. So 2 pi equivalent fraction is 36 pi over 18. And then we're going 1/2 revolution right here, which is pi or 18 pi over 18. And then we're going a quarter, okay, a quarter rotation, which is going to be 9 pi over 18. That takes us to this axis, and then we're subtracting this one because that's coming from here. We're subtracting 7 pi over 18. We crunch some numbers. 36 plus 18 plus 9 minus 7 pi gives us 56 pi over 18. These both have a common factor of 2, so we can factor that out, and we're going to get 28 pi over 9 for the angle that rotates 1 and a little bit past a 1/2 revolutions in radians. Okay, so for these guys, what we're doing is we are finding the exact value of the trig function given. So we're trying to find the secant of theta for this 210 degree angle. So what do we know about a 210 degree angle? Well, we know that its terminal side is in the third quadrant. And in the third quadrant, this secant is going to be negative because only the tangent and cotangent are positive. Sine, cosine, secant, and cosecant are all negative. So what we're going to use, remember the hint is when it says exact value, we're probably going to be using a reference angle. So the reference angle here, from the terminal side to the closest x-axis, our reference angle is 30 degrees. Okay, so we don't really memorize them for secant, but secant is the reciprocal of the cosine. So the cosine of 30 is what? Cosine of 30 is what? Think about that for a second. Remember on our things, it is going to be rad 3 over 2. Agreed? Okay. And the reciprocal of cosine is the secant, which is what we're looking for. So the secant of 30 is going to be the reciprocal of rad 3 over 2, which is 2 over rad 3. When we rationalize it, it's going to become this, 2 rad 3 over 3. And in the third quadrant, the secant is negative. So the secant of 210 degrees is going to be minus 2 rad 3 over 3. Okay, for this one, this is in the first quadrant. So first quadrant, that's already an acute angle. Okay. Okay, so our angle is 60 degrees, so the angle is the reference angle. So we have to figure out what the cosine of 60 degrees is. Okay, in the first quadrant, all the trig functions are positive, so the cosine of 60 is 1/2. And that is our answer. Cosine of 60 is 1/2. So for our last two problems, we have to find the tangent of theta, and theta is negative 495. So that means we're starting our standard position. We're rotating around one time, which is negative 360, and we're going past vertical, so our reference angle will be coming off of here, which is going to be negative 540. From negative 540 to negative 495, our reference angle is 45 degrees. Okay, so 45 degrees for a reference angle, that'd be that. Okay, the tangent of 45 equals 1. And in the third quadrant, which is where our terminal side lands, the tangent is positive. So therefore, the tangent of negative 495 degrees is equal to 1. Okay, for this guy, same type problem. On this one, it's positive 495. So this is going around one full revolution and a little bit less than a revolution and a half. So this, again, would be 540 for our reference angle. From 540 to 495, the reference angle is also equal to 45. Tangent of 45 is equal to 1. In the second quadrant, the tangent is negative. So the tangent of 495 degree angle is equal to negative 1.